Hello everyone, welcome to WB Institution, the online education app. In the previous classes we have discussed about, now let us calculate the axial load and amount of torque transmitted in single plate friction clutches. So here we have to calculate axial load, that is W, with respect to R1 and R2. So we have seen in the diagram previously, that is we cannot concentrate on the whole element. Let us take a single element, that is a strip, which we have shown there in the previous note, that for that element we can calculate the area and the amount of axial load applied on that element, and if we differentiate that with whole radius, whole element, then we can get the whole axial load which is acted on the clutch plate. Now this area of that element dA is given by 2 pi r into dr. So that is the area of the element, only that element, a small element in that whole friction linear. So the axial load on that element dW will be equal to P into dA. So P is the pressure, amount of pressure acting on the clutch plate, and dA is the area of the element. Now this will give us the value of dW, which is P into 2 pi r into dr. Now if we differentiate it, we get the amount of load which is axially acting on the driven shaft, that is W equal to integral R1 to R2 dW. So here dW is integral R1 to R2 P into 2 pi r dr. Let us say this as equation number 1. Now next, in the similar way, torque. So let us assume the torque in the values of R1 and R2. Now the friction force on the element, the amount of friction force acting on the element is given by dF equal to mu into dW. So here dW we have calculated previously. If we substitute that value, then we get the value of dF, that is mu P into 2 pi r into dr. Now the torque due to friction on that element will be given by dt equal to dF into r. So here we have calculated dF. If we substitute the value of dF, then we get the equation T equal to integral r1 to r2 mu into P into 2 pi r square into dr. So here we have calculated directly the total amount of torque acting on the liner. So this will be the equation number 2. Now there are two equations, one is for the axial load and other one is for the amount of torque transmitted. Now we cannot directly differentiate these equations. Why? Because we don't know the relation between P and R. So here P and R, here P and R. So other values are constants. Whether P and R are constants or not, we cannot derive directly. So for that there are two theories. One is uniform pressure theory and other one is uniform wear theory. So let us explain it in detail. So let us take this as a clutch plate. So there is a friction liner and we have said that a force will be acting on it continuously. So if a P amount of pressure is applied on the clutch plate, if this P is constant throughout the length of this area, that is R2 minus R1, in this area the amount of pressure is equal throughout this R2 minus R1, then we can say it as an uniform pressure theory. So if in the same clutch plate, these are the friction liners, so if the pressure is varying with respect to the radius of this, then we can get it as a pressure which is uniform wear theory. Here the pressure is varying in between uniform pressure theory and uniform wear theory. So here the radius is R1 and here the radius is R2. Here at this R1 the pressure is max, P max. So and at R2 the pressure is minimum, P minimum. In this condition the pressure is constant. So throughout the radius it is constant. So this is simply about uniform pressure theory and uniform wear theory. So where does we get uniform pressure theory and where does we can say uniform wear theory? So if a clutch is newly introduced in the mission element, then we can say it as a uniform pressure theory. If it is an old mission element, then we can say it as an uniform wear theory. We can say the friction liners have been weared. So let us consider two equations, both the equations, and we calculate the value of W and T. So the value of W is given by according to uniform pressure theory, where the pressure is constant. So we have the equation 1 here. So we have to substitute the value of P and we have to derive the equation. If we know the pressure is constant, then we can easily take it out of the integration. Then we can write the equation as P integration R1 to R2 2 pi R into dr. So 2 pi is also constant. We can take it out, and if we integrate R1 integral R1 to R2 R into dr, then we get the equation as R2 square minus R1 square divided by 2. Then 2 and 2 gets cancelled. The final equation of the axial load under uniform pressure theory for single plate clutches is given by W equal to P into pi into R2 square minus R1 square. In the similar way, the torque. So torque, if we take the elements pressure, coefficient of friction and 2 pi as a common elements, then we can write the equation as T equal to mu P into 2 pi integral R square dr from limits from R1 to R2. So if we integrate this equation, then we get mu P into 2 pi R2 cube minus R1 cube divided by 3. So this is the equation for the torque transmitted in the clutches, in the single plate clutches under uniform pressure theory. So in the similar way, let us calculate the values of W and T under uniform wear theory. So in uniform wear theory, the rate of wear will be directly proportional to P into R. So the pressure, if the pressure is maximum, then the radius is minimum. If the pressure is minimum, the radius is maximum. Here we can see it. So in that, if the rate of wear is directly proportional to P into R, so let us take the amount of P into R as a constant. Then we can write the value of P equal to C by R, where C is the constant value. So in this equation, if we substitute this P equal to C in the equation 1 and 2, then we get W equal to integral R1 to R2 C by R 2 pi R into dr. Here R and R gets cancelled. So and if we take the constants out and if we integrate the equation, then we get C 2 pi into R2 minus R1. In the similar way for torque, if we substitute the value of C by R, then we get integral R1 to R2 mu into C by R 2 pi R square into dr. So here 1 R gets cancelled and the equation gets T equal to C mu into pi into R2 square minus R1 square. So this is the equations which we have to keep on mind. All these 4 equations, that is under uniform wear theory, uniform pressure theory for the values of axial load and the torque transmitted in the clutches. So this is entirely about single plate clutches. In the similar way for multi-plate clutches, what will be the difference? Here we can see a shaft which is running with multi-plate clutches, the driver pulley and driven pulley. There are multiple plate clutches. So 1, 2, 3, here in this example there are 3 clutches. So the amount of construction is very small. So if we want to increase the friction, coefficient of friction in single plate clutches, what we have to do is we have to increase this area. So we have to increase this area. If we go on increasing this area, then the construction of the clutches will be a bigger in size. So if we use multiple clutch plates, then the coefficient of friction which we get and the torque transmitted will be maximum as compared to single plate clutches. These are the differences between single plate and multi plate clutches. So in the similar way, let us calculate the torque and the axial load. So the torque which we have calculated for single plate, if we multiply for number of plates, then we get the net amount of torque, that is T multi equal to N into T of single, the torque of single clutch plate. So this is about torque and axial load. In axial load, even for single clutch plate or for a multiple clutch plate, the axial load, the amount of load acting on the clutch plate will be constant for n number of plates. That is, W multi will be equal to W single. So we need to keep in mind about these four equations: 1, 2, 3, 4 for single plate clutches. Also we have to keep in mind that is, they may ask in the change of pressure. So we have to keep in mind all these equations, which are very important at the time of calculation of problems. So in the multi-plate clutches also they will ask questions, but directly we can calculate for single plate clutches, and for torque transmitted we have to multiply it with number of plates which they have mentioned in the question.